Okay, let's give you guys some examples. So we've seen this theorem in the past. In this video, we're going to determine if this alternating series will converge or if it will diverge. So we need to check these 3 points. So the first one, make sure all the UNs are all positive. So when you look at your alternating series, you need to isolate this UN. You need to isolate this UN. So when given this here, in your mind, visualize it like this. In your mind, break this up. So this is like one block, and then you're actually multiplying, because when given this, you would multiply this to the top. You would multiply it to the top. So visualize this as this in your mind. So this is your UN here. This is your UN. So when given this this alternating series, isolate this in your mind. So isolate this in your mind, and then when you come to visualize the UN, UN is really 1 over n for this case here. So isolate this bit here. Well, anyway, so you need to check, make sure that all the UNs are all positive. So 1 over n, that's for this case here. 1 over n, well, if you 1 over n is a bit like 1 over x graph here. So when it's 1, this is 1. When it's 2, is a half. When it's 3, it's a third, and so on. So you can see that this thing here will never cross into the negative realm. It will always be positive. So this 1 over n will always be positive. So this is good. So now the next one, make sure that eventually it's going to be non-increasing. So well, what it's saying is that this eventually thing here is, if you have a sequence that's something like this, then this here, let's say this is n equals 1 here. So eventually means that there exists a capital N. There exists a capital N where it will always be true beyond that capital N. Basically, you only care about the tail end of the sequence. But in our case, not it will always work. In our case, it will work for n equals 1. Beyond that, it will always work. But if you have this thing here, if you have something like this, then here eventually there exists a capital N where beyond capital N it will always work. So this is okay. You only care about the tail end of the sequence. Well, anyway, for the second point, make sure that all the UNs are non-increasing. So in a way, not non-increasing. Make sure it's going downhill all the time. It could stay the same, but then it has to go downhill. It can't go uphill. So for 1 over n, there are 2 ways of doing this. Well, you making sure that it's always going downhill or staying the same. It's really you checking that the next term is less or equal to the current term. So suppose you have something like this. This is your next term, un plus 1. This is your current one, un. So make sure the next one is less than or equal to the current one. So there are 2 ways of doing this. When it comes to un plus 1, when it comes to 1 over un, this un plus 1 will be 1 over un plus 1. Un plus 1 will be 1 over n plus 1. Now this thing here is just un here. So clearly you can see that this is less than this. So this is true. You see, in the case of 1 over n, this technique is easy. This technique is easy when you just add 1 to this thing here. It's easy. But in the future it will get complicated. So you can't just simply use this technique. The other technique is to do this. Turn it into a function. So you've got your sequence like this, and then by you doing this, you map a function on top of all your terms. So you can think of it as this, and then look at the derivative. Well, the derivative is negative 1 over x squared. Well, 1 over x squared is positive, and this is positive. So this is negative. So 1 over f prime will always be negative. So you know that it's always going downhill. So when you come to check this, there are 2 ways of doing it. One So when it comes to 1 over n, two ways of doing it. One is to look at this. When it's nice and simple, this is good. This is nice and easy. So you know that this is going to be less than this. The other way of doing it is to turn it into a function, 1 over 1 over x, and then look at the derivative. So this tells you that it's always going downhill. The if the first derivative is negative, it's always going downhill. So in our case here, this is good. So far this is good. This is good, and make sure the limit heads towards 0. So if you look at this limit as n tends to infinity of 1 over n, you know this is going to be 0. So this is good. This is good. This is good. Therefore, the whole alternating series will converge. Okay.